All right, so we're in section 10.1. Talking about trigonometry. Today we'll talk about tangent ratios. So in our opener, we started out, had a little introduction into what we were going to talk about. So trigonometry has to do with similar triangles. So I'm going to draw a couple of triangles here, and we'll label some things. So we're going to say that these two angles are congruent, and this is a 90-degree angle. And we'll call this triangle ABC, and this triangle MN and O. And in our opener, we decided that triangle ABC was similar to triangle MNO by angle. And in chapter 8, we talked about what we knew about triangles if they are similar. We know that when we have similar triangles, that their corresponding sides are proportional. So this tells us we can write that BC over AC, this side divided by this side, and we're talking about lengths here, equals NO over MO. So the length of this side divided by the length of this side equals the length of this side divided by this side. When we have similar triangles, that will always be the case. And we also talked about how no matter how big the triangle is, as long as it has a right angle and they share this angle, then no matter how big, they're still going to be similar. So these ratios will always be the same. We'll be able to write this proportion for those two triangles no matter how different they are in size, as long as this angle is the same as this angle on the triangle. So that leads us to our first, what we call our first trig ratio. And trigonometry just means trigon is a triangle, and metry comes from meter, which means to measure. So we're measuring triangles. That's what trigonometry is all about, is measuring triangles. So the first ratio that we're going to talk about, and it all has to do with ratios, is the tangent ratio. So we'll draw a picture and we'll define our tangent ratio. I'm going to go the other way. I'll make it down here. There we go. So for this triangle, we're going to say that this is A. And in triangles in trigonometry, I don't know why it's kind of what they've picked, but we usually name the angle this symbol called theta. So this is theta. And this is our 90-degree angle. This side is adjacent to theta, just means it's next to. And this side we call the opposite side because it's across from theta. So for this triangle with the angle theta, we can also call it angle A. We are going to say that the tangent of A, and the way we write it, we can write it in a couple ways. The tangent of angle A, or tangent of angle A, or we write tangent theta equals the length of the opposite side over the length of the adjacent side. So this is how we define our tangent ratio. It's the opposite side over the adjacent side. And what we figured out from our opener and from what we talked about here is that no matter how big the triangle is, how big or small, that if it has this particular angle, that the tangent ratio for those triangles is always going to be the same. So the tangent ratio really has to do with the angle. If we have a 90-degree angle and some other angle, the tangent ratio tells us about the angle. And for all of these that we're going to talk about for the next couple of days, it has to do with right angles, right triangles. We have to have a 90-degree angle and one other angle that we're interested in. The tangent ratio for that angle is always going to be the same. So let's talk about how we use the tangent ratio a little bit. We'll calculate them and then we'll solve some problems with tangent ratios. So is everybody good with what we have here? Okay. So here's our triangle. And we have, this is our angle theta, and this is 5, and this is 4. And we want to find the tangent ratio of this angle. So the first thing we want to do in all of these kinds of problems is let's label our sides. So is 4 opposite or adjacent to the angle?
Adjacent.
Adjacent, it's next to. So I'm just going to label it this way. So 5 is going to be the opposite side. And this side is always going to be, the long side is always going to be the hypotenuse in a right triangle. So the tangent is the opposite over the adjacent. So we write that the tangent of theta is 5 over 4. And that's approximately 1.25. So a problem like this would say, write the tangent of the angle as a ratio. And this is what it's asking you to do. Just put the opposite side divided by the adjacent side. So let's look at another example. That's all there is to this kind of problem. If it gives you the sides of a triangle and says calculate the tangent ratio, all it's asking you to do is put the opposite over the adjacent. And that's it. Let's look at another example. We'll do it a little differently this time. We'll draw the triangle this way. And this time, this is our angle theta. This is 7. And this is 3. And we want to find the tangent ratio for the angle. So let's label our sides. Is 3 the opposite or the adjacent? Opposite. It's across from the angle. So 7 is the adjacent. Adjacent is next to. So the tangent of theta as a ratio is opposite divided by adjacent. 3 over 7. Or approximately 0.42. So if they give you the sides of the triangle and they want the tangent ratio, this is all you have to do. Just put the opposite side divided by the adjacent side. Questions on that? 0.42, yes. So we decided that if we have a right angle and some other angle, that the tangent ratio has to do with the size of that angle. No matter how big the triangle is, as long as it has the same angle, it's going to have the same tangent ratio. So the tangent ratio tells us something about the angle. We can use our calculator to figure out tangent ratios, and we can use our calculator to figure out angles. So let's talk about how we do that. So we want to figure out how to figure out tangent ratios on the calculator. So if we know the angle, we use the button that says on your calculator tan. So we use the tangent button to find the ratio. Yes, on your scientific calculator it'll have a button that says tan. So if we know the angle and we want to find the tangent ratio, we use our calculator. So let's do a couple of examples. We have, the problem would say something like, use your calculator to find the tangent ratio of 47 degrees. So in my calculator, I'm going to use the tangent button and 47 degrees. Now, some calculators are different. What I have here is the TI-84. Most of the Texas Instrument calculators are going to be similar to this. So what we are going to do is I'm going to use the tangent button, which is right here on this calculator. Tangent of 47 equals 1.07. If your calculator doesn't tell you that, it might be in the wrong mode, and we need to make sure it's in the right mode. We can talk about the modes of your calculator if you want to ask me about it in a little bit. So I just plug that into the calculator, and we said that that is, sorry, I forgot what it was, 1.07, about 1.07. So if we have the angle and we want the tangent ratio, we use the tangent button on our calculator. If we want, we'll do another one of these. Tangent ratio for 82 degrees. I'm going to use the tangent button, and I'll hit 82 degrees. So in the calculator, and I should put approximately equal because we rounded it. So our tangent ratio, I'm going to clear that. I'm going to do tangent 82 equals about 7.12. And that's all there is to it. So I'm going to go back here and I say that's about 7.12. So if we know the angle, we use the tangent button to find the ratio. Now we're going to go the other direction. Questions before we move on? If we know the ratio, we use the inverse tangent button. On your calculator, it will look like this. Or it might look like this. We use this, the inverse tangent button, to find the angle. So if we know the ratio, we use the inverse tangent button to find the angle. So the problem on these might ask you something like, the tangent of my angle is 4/5. Find theta. So we want to find the angle. To find the angle, we use the inverse tangent button. So let's look at how we do that on the calculator. Clear this out. So on this calculator, the inverse tangent is this shifted button up here above the tangent. So I'm going to do second inverse tangent of 4 divided by 5 equals about 38.66 degrees. So let me go back and I'll say this is theta is the inverse tangent of 4/5, which was approximately 38.66. So to find the angle, we use the inverse tangent. Let's look at another example of that. Let's find the inverse tangent of 6.3. So on our calculator, we're going to do inverse tangent of 6.3. And that is about 80.98 degrees. So when we're looking for an angle, we want to find the inverse tangent, we use the inverse tangent button. Let's do one more. The other way they might ask it is find the angle with a tangent ratio of 7/8. So the problem asks us to find the angle. To find the angle, we use the inverse tangent button. So we're doing the inverse tangent of 7/8. And we'll go to the calculator, the inverse tangent of 7/8. So I'm doing inverse tangent. I'm going to do 7 divided by 8. And I get 41.1, about 41.12 degrees. So when we want the angle, we use the inverse tangent button. When we want the ratio, we use the tangent button. Questions? All right, let's talk about how we solve problems with tangent ratios. So I'm going to give you some steps for solving problems. If you follow these steps, your problems will come out right every time. So the first step is you want to label the sides of the triangle. So label the triangle. And what I mean by label the triangle is you want to figure out which side is opposite and which side is adjacent. So just like we did right at the beginning, we labeled the sides. Second step, we want to write an equation. And our equation is going to be, it's always for tangent ratios. Our equation is going to say that the tangent of the angle that we're interested in equals the opposite divided by the adjacent. So we're always going to have some angle that we're looking for, and we want to do the tangent of the angle equals the opposite over the adjacent. Our third step is going to be solve for the part that we need. So we'll have an equation. We've solved for the part we need. We've done that a lot this year. And the fourth step is at the end, we're going to plug numbers into our calculator. So if you follow these steps, when we use our tangent ratios, your problem should come out right every time. And we'll do a similar set of steps when we talk about the other trig ratios a little later. We'll have 3 different trig ratios that we're going to use. Today we're just talking about the tangent. All right, questions on our steps? Let's apply these to some problems. So here's our triangle. And we're going to say that this angle is 47 degrees. This is 90 degrees. This side is x, and this side is 7. And we want to find x. So let's follow our steps. Our first step is label the triangle. Is x opposite or adjacent? Opposite. It's across the triangle. So this is opposite. 7 is adjacent. The longer side is always the hypotenuse. We'll talk about the hypotenuse later. Now we're going to write our equation. Our equation should look like the tangent of our angle. Here's the angle that we're using. The tangent of 47 degrees equals the opposite, x, over the adjacent, 7. Now our third step, solve for what we need. We're looking for x. So how do we get rid of the 7 in the denominator? Multiply. So I'm going to multiply both sides by 7. Those cancel. And I'm just going to turn this around and say x equals 7 times the tangent of 47 degrees. And then our last step was to use our calculator. So I'm going to plug this into my calculator. 7 times tangent 47. So let me clear this out. Yeah. So in my calculator, I'm going to put 7 times tangent of 47 equals 7.51, about 7.51. So this side of the triangle would be about 7.51 units. Questions on that? Just follow the steps and your problems will come out fine. Let's look at one that usually people find a little trickier. Is everybody good with this one? All right. So I'm going to, here's my triangle. And this angle is 62 degrees. This is x, and this is 9. And we want to find x. So let's follow our steps. Let's label our triangle as 9 opposite or adjacent. This is the angle we're interested in. So 9 is opposite. X is the adjacent. Second step, write our equation. The tangent of the angle equals the opposite divided by the adjacent. So there's our second step. Our third step is solve for what we need. Well, what we need is this x down here in the denominator. How do I get rid of this x in the denominator? What do I need to do? What is it? Multiply each side by x. So I'm going to multiply by x. On this side, the x's cancel. And I get x times the tangent of 62 degrees equals 9. I still need to get x, so how do I get x by itself now? Divide. Tangent of 62 degrees is just a number. So I can divide by that number. So I'm going to divide both sides by tangent 62. And on this side, the tangent of 62's cancel. So I get x equals, let me get changed back to black here. X equals 9 divided by the tangent of 62 degrees. And then my last step is to use the calculator. So now I'm going to go to the calculator, clear this out, and I'm going to do 9 divided by the tangent of 62 degrees, and I get 4.79. So x is approximately equal to 4.79. Questions on that? All right. Homework. Oh, sorry. Page 635.